In this video, I will show you how to perform confirmatory factor analysis in JASP using the data file that I explained above. So my JASP software is already opened, and next I will open the data file using the CSV file that I just created out of SPSS. So I go to Open, Computer, Browse, and I select the file, and as you can see that JASP can read all these formats. So it can read SPSS format, text format, CSV format, and a couple others. So I click Open, and here is my data. Let me explain a little bit about JASP. First, you see the data. If you click on this is where you would run analysis, and we would specifically run factor analysis, confirmatory factor analysis. So let's go there and click on it. So I went to factor, press on the arrow here, and click on confirmatory factor analysis. Now, before I will proceed, on the right and middle and sometimes left sides, you'll see these arrows that is for extending certain screens. To view the data, you would click on this arrow all the way on the left, and you can see the data. To go back to the menu with the analysis, you would click on the right part of your screen. This is essentially should look very familiar to you, because this looks very similar to how SPSS menu looks like. In SPSS, you obtain results in a separate window. Here you have like a separate tab which you can also extend, and you will be able to view the results. So now you see there are two arrows here. One will allow us to go to the menu to run analysis, and one will bring us back to the data. So before we start entering the variables for the analysis, we need to change our variables for scale data. So let's go to the data by clicking on this arrow in the middle on the left side. And as you click at the top, you can change the variable type or the column type. So what we want to change all these variables to scale data. So one after another, I'm just clicking one after another. If you don't do this step, you will not be able to enter these observed variables for the factor analysis. So now that they are all changed, let's go back to our menu to run the confirmatory factor analysis. So right now I'll click on the arrow to hide the data. And here, as I explained in the previous video, we have three factors: master goal orientation, performance goal orientation, and then academic identity. So master goal orientation, let's enter it as a factor 1. I just highlighted the three of them. I use Shift to highlight them. So I highlight first item, I press Shift, and then I click on the last item. You can do them one by one, that's fine as well. And then I click here to move the items. Next, I add one more factor, and I will move the same way item 4, 5, and 6. Right now I was holding Shift and was just using the arrows, moving them down. So that's another way to highlight all items. And finally, factor 3, which is our sense of self or academic identity, the 5 items. So right now we specified through factor model, but before we can proceed, we should also change some or indicate some of the options. First thing that I would like you to indicate is model options. So if you extend this menu, you can see these options here. I'm sorry, I apologize, I'll be using it like this. The residual covariances, these are those variances of specific items that in the lecture video I stated that almost most of the items, or more or less no items, should have these residual variances correlated. Therefore, we will just will not do anything under the model options. But we want to check additional output, and specifically want to check the fit measures, SRMR, TLI, CFI, and RMCA. Those are the ones that we spoke about in the lecture. Other useful measures could be AIC, BAC modification indices, but because we have a very brief course, I'm not focusing on them during this week. You can skip multi-group CFA, but let's also ask for a plot. And we want model plot. And you can also ask to show parameters. So every time you specify something here, you can see that things change in results. So this program runs results right away, which is very helpful and very useful. Now the last menu is advanced, and it was kind of like hidden in my screen, but make sure that you also check this last menu. And what I want you to check here is that we also include standardized coefficients, so check standardization all. So now we are ready to view our results. Before we will look at model fit, let me show you the model itself. So I'm gonna hide the input options and just focus on results. If I scroll all the way down, here is our model diagram. We have three factors: factor 1 with 3 items, factor 2 with 3 items, and factor 3 with 3 items. So these are our latent variables, and we have observed items or observed variables here at the bottom, denoted by squares. Our item variances are indicated by this double semi-moon-like arrowheads lines in this program. You can also see factor loadings here, but these are not standardized factor loadings, so they can be above 1.0 and below 1.0. These are the correlations between the latent factors. But all this data, all the statistics are presented in the tables above. So let me scroll all the way up, and let's just walk through, and let me point to you what you would be including in the results. First thing is chi-square statistics. So the chi-square value would be of the factor model. You would just skip the baseline model. Factor model is 104.46 with 41 degrees of freedom, and this chi-square test is significant. So what we want to see here, we want to see a non-significant chi-square, but as I mentioned in my lecture slides, it is very rarely non-significant in social studies, just because of the nature of the data. This is why we requested additional fit indices, and these are all fit indices that I spoke about in the lecture. Recall that we want to see TLI and CFI above 0.90, and it's even better to see when they are above 0.95. So these two indices show that the model fit is good. We want to see RMCA and SRMR below 0.08. So we can see that the fit of the model is good. Next, let's take a look at our factor loadings. Factor loadings are the same what you did or what you reported in your outputs during last week, and I saw that some of you even highlighted them with yellow color. So let me just point to you where you can find it in this table. We have three factors: factor 1, factor 2, factor 3. Factor 1 with 3 indicators, factor 2 with 3 indicators, and factor 3 with 5 indicators. We have unstandardized estimates here, and these values would be above and below 1.0, so that's fine. Then we have standard error z-value that is obtained by dividing estimate by standard error, and the p-value. Here we want to see each of these estimates significant. If p-value is indicating non-significance, that would imply that the item did not really load high enough on the specific factor. So there is misspecification in the model. Confidence intervals for the estimate for this, and then here is our standardized estimates. So these are you should expect to see them to see these values below 1.0 and above at least 0.4, but essentially you should be familiar with these values because that's what you reported from SPSS for factor loadings. So these are our factor loadings. In your homework, please highlight these factor loadings. Next, we can skip factor variances because all of them are set at 1. But let's take a look at factor covariances. So factor covariances is essentially correlations between the factors. So you can see that correlations between factor 1 and factor 2, or master and performance goals, is 0.634. Correlation between master goal and academic identity is 0.585. And correlation between performance goal and academic identity is 0.608. You can see that all these correlations are statistically significant. So that would be something interesting to report as well. You can also see that estimate for correlations or factor covariances and standardized estimates here are the same values, which would be expected because covariances or correlations themselves are standardized. This is a table of residual variances, and you can also skip it, and the plot you've already seen. So that's how you would be conducting this analysis. Something else that you can also do, let me just show you very quickly. You can label each factor. So you can say master goal, performance goal, and then academic identity. And this will help you very much as you will be looking at results. You can see that now it's very clear which items belong to which factor, and you do not need to memorize what is factor 1, what is factor 2, what is factor 3. And these tables would be ready for your reports or publications. And you can see that in the model plot, it's pretty cool how the latent variables are being labeled here.